Today, we're going to review how to find the oxidation numbers for each atom within a molecule in order to determine which atoms gain or lose electrons during a reaction. Before we dive into the practice problems, it is important for you to be familiar with all the oxidation states so that it is easier for you to determine which atoms are being oxidized or reduced within the equation. Here, I have listed all the oxidation states you'll need to complete the following questions. Pause the video if you need some time to go over them. Additionally, you should know that oxidation means that an atom has lost electrons, while reduction indicates that an atom has gained electrons. You can remember this using the abbreviation OIL, which means oxidation is the loss of electrons, and RIG, which means reduction is the gain of electrons. Alright, so let's begin with question 1, which asks us to find which atom is oxidized and which atom is reduced within the equation where zinc chloride is combined with silver 2 sulfate to create silver chloride and zinc 2 sulfate. Take some time to try and figure out the question on your own and then come back to the video to check your answer. Alright, so if we look at ZnCl, we can see that there's no overall charge for the molecule. This means that the oxidation numbers of the atoms used to create the molecule must add up to 0. Using our oxidation state rules from before, we know that the chlorine atom has an oxidation number of -1, and with this information, we can predict that the oxidation of the zinc should be a +1 because in order for us to ensure that the ZnCl has no charge, we need to even out the chlorine's oxidation number, which is a -1, with a +1. Now, when we look at the product side, we see that the zinc has combined together with the polyatomic ion sulfate to create zinc 2 sulfate. This molecule, the oxidation number of the zinc is now +2 because when you assign the oxidation number for the 4 oxygen atoms in the sulfate, which is total up to a -8, and the sulfur atom, which is total up to a +6, the molecule is going to be left with an overall charge of -2. However, because the equation shows us that the zinc 2 sulfate has no overall charge, we can predict that the zinc has an oxidation number of +2 so that the charge can be evened out to equal 0. So, the increase in oxidation number of zinc from +1 to +2 indicates that the zinc was oxidized and that the atom had lost an electron during the reaction to become a bit more positive. Now, if we look at the silver 2 sulfate, we can see that the silver has an initial oxidation number of +2. However, after the reaction, we see that the silver has paired up with the chlorine to create silver chloride, and since chlorine has an oxidation number of -1, we can predict that the silver should have an oxidation number of +1. The decrease in the oxidation number of silver from +2 to +1 indicates that the silver was reduced and that the atoms had gained an electron during the reaction. Alright, so for the next question, we have the equation where difluorine monoxide is being paired with the nitrate polyatomic ion and 4 hydrogen ions to create 2 water molecules, 2 molecules of nitric acid, and a diatomic fluorine molecule. So I'm going to assign the oxidation numbers to each atom using the oxidation state rules from before. The fluorine on the reaction side has an oxidation number of -1. However, the oxygen is going to have an oxidation number of +1 because of the rule which states that the oxidation number for oxygen changes from a -2 to a +1 when it's paired with fluorine. In the nitrate polyatomic ion, the nitrogen will have an oxidation number of +5, and the 3 oxygen atoms will each have an oxidation number of -2, which combine to be a -6. Finally, the hydrogen will have an oxidation number of +1, which combines to be a +4 total. On the product side of the reaction, the hydrogen will have an oxidation number of +1, and the oxygen will have an oxidation number of -2. In the nitric acid molecule, the nitrogen will have an oxidation number of +5, the oxygen will have an oxidation number of -2, and the hydrogen will have an oxidation number of +1. Finally, the fluorine gas molecule will end up with an oxidation number of 0 because it's considered as a diatomic molecule, which means that both of the atoms of fluorine have an oxidation number of 0. So in this case, because the oxidation number from the fluorine monoxide molecule changed from a +1 to a -2, we can say that the oxidation was reduced since it gained 3 electrons. On the other hand, because the fluorine's oxidation number changed from a -1 to a 0, we can say that the fluorine was oxidized and that it gave away an electron during the reaction.